My name is Owen McLaven. I've been in the industry for over 30 years in fixed wing and rotary wing. Every day I get challenged by people who are much smarter than me in their field of expertise, and that's what makes this job fun. We have a lot of flexibility, a lot of passion, huge motivation. Some people ask me what our customers want. I see our customers as people just like you and I. They want peace of mind, they want responsiveness, agility, excellence in engineering. But above all, they want quality, speed and value.
Wind 210 degrees 5 knots, runway 28, clear takeoff.
Aviation is an exciting industry. It represents travel, it represents meeting new people, seeing new places. Even though we work with companies, we work with airlines, we work with leasing companies, it is still a business about people. So interacting with people on a daily basis is what my job is to understand the customer needs, the timetable, the work scope, the budget. We have a flexible workforce, we have top engineers that help create that specific work scope for the customer.
In the process of designing the best solutions to our customers, we very often have to disrupt the way we see things, the way we do things, and the way we would approach normally the problems. This is really what I prefer in this company. The openness from bottom up and top down of our management to explore and be open to developing new services for our customers.
What we tend to do with every work scope package that we offer or recommend towards our customers is to make sure it fits their individual needs and criteria. Within the engineering team, Marco Evener takes care of customer support engineers. So he is involved much earlier on in the starting of the shop visit of an engine. So he's the one talking directly to the customer, trying to figure out, okay, what are your needs, what are your criteria, what is important to you, what do we need to lay focus on?
The first process where we actually step in is during the bidding phase. The product management is sharing all the data they receive from our customers so we can review the fleet. We will be able to make a comment on the modification status and the condition of the fleet in general.
Once we have a deal signed with our customer, is to make sure that all the necessary documentation is fed into our system as early on as possible, so the work scoping process can start as early as possible.
Once we sign the customer contract, the product management will do a handover to the account management team. Then the account manager takes the ownership about managing the entire shop visit process. We have various steps in the whole pre-induction process to basically make sure that we have the contract ready, we have the customer slot available, we have all the paperwork and work scope defined, and the engine has arrived at SR Technics, and basically we have finished the pre-inspection and boroscope inspection, so the engine is ready for the shop.
Die Triebwerke, die wir hier in Zürich bekommen, die werden zu 95% mit den Lastwagen von den grossen Frachtflughäfen in Europa werden die angeliefert. Nur ganz wenige Triebwerke werden hier in Zürich direkt vom Flugzeug abmontiert und kommen dann nachher zu uns in die Überholung oder die Reparatur. Das Triebwerk wird vom Lastwagen oben abgenommen mit dem Gabelstapler und wird bei uns in die Halle gestellt und kommt dann die Incoming Inspection über.
From time to time, customers come to us with what could be seen as an impossible equation. Have more for less. This is typical. And sometimes we manage to make it happen. Very recently, a customer had an in-flight shutdown. His entire high-pressure compressor was wiped out. The engine was beyond economical repair. Impossible to make it work. We managed to find a replacement module that we had to overhaul, but still made the customer save $1 million. And the customer is still operating the engine today.
In today's environment, every customer is unique. Some customers are looking at the price as the differentiator. Others are looking at the majority of parts being used serviceable condition. So each customer is different. We need to create a customized solution for each one. Turn time may be important to one, price may be important to another one. The support of a lease engine may be important for yet another customer.
What we tend to do with every work scope package that we offer or recommend towards our customers is to make sure it fits their individual needs and criteria. It's all about the customer. First step that we do once the engine arrives here at the so-called turbo hall is unwrap it and put it on pedestals. This is the moment where we can start the incoming inspection. The incoming inspection consists out of an inventory check, a visual check for transportation damage and suspected unapproved parts, a completeness check, a borescope inspection, and a filter check. The inventory check is done by Vocollect system. This is a system where the inspector wears a headset and reads out every part and serial number of the components attached to the engine. That information is fed into our SAP system and can be used for further work scoping and part processing. Next, what we do is we take a lot of pictures of the engine. First of all, to record the engine condition during incoming, to check for transportation damage, handling damage, and the check for so-called suspected unapproved parts. The borescope inspection is important to figure out what the condition is of the gas path of the engine. This is important information to have in order to substantiate and to control what the planned work scope relates to in terms of the actual condition of the engine. The filter checks are being done to ensure that the oil and fuel system are completely clean, have no further contamination, or do not show any signs of material deterioration on the bearings or accompanying hardware. The purpose of the incoming inspection is to have all that information passed on to our customer support engineer. They're the ones then fine-tuning the final work scope with the customer. The work scope consists out of the basic information of the engine, the reference according to which the customer would like us to work with, the disassembly level, the life-limited part strategy, the material strategy, mandatory and optional modifications, on-wing maintenance requirement items, test and certification requirements, and the preservation and shipping back to the customer.
We have finished our incoming inspection, and I would like to show you what has been found and how we can address the vibration issue.
Oh great, the vibration was a big problem on wing.
Looking at the gas path, no deviations were found. The most probable root cause for the vibration is a high-pressure turbine damper sleeve.
In this case, we have tendency to believe that the damper sleeve is broken. This is one of the most probable root causes for N2 vibration. In order to do this, we have to remove the LPT major module, the module 53, which is the LPT nozzle and HPT shroud module, and the HPT rotor. Once the HPT rotor has been removed, that's when we get access to the broken damper sleeve. Once we have clarified all findings and repaired all necessary parts, that's when we can start reassembly of the engine.
Once exposed and inspected, we can confirm the root cause for vibration and share the inspection results with you.
Thank you. Good day.
Goodbye.
Once the work scoping is complete, the engine is being put onto a transport stand and transported into our engine shop. At the same time, all the necessary preparation steps are being done. Creation of shop order, creation of the necessary work documentation, and the instruction to the mechanics. Once that is completed, that's where the shop visit starts. raus. Ja. Gemäß dem. Tun wir das so machen.
Ja,
ist gut. Tun wir das als Review aufnehmen. Ja. Gut.
Ich würde Ihnen empfehlen, das nochmal separat zu lernen, das Foto machen. Das wäre sehr gut.
Das machen wir.
Ja.
Hi, my name is Fabrizio Spina. I'm the supervisor at the engine line department. Let me show you what we do. After we receive the shop order from the tech supporter, we pick up the engine and hang it on the so-called gantry. The first step is to remove all the tubes, harness, brackets and components. As next, we focus on the module removal. After the module is removed, we get more insight about the condition of the engine. This is important for the further process of the module. Based on the pre-inspection, the module goes either to the inspection department or to the module disassembly department.
After module inspection is completed, and that shows that we need a work scope upgrade, we need to liaise back with our customer. If the work scope upgrade has been approved, that's where we continue with module disassembly, either partly or to part level. Then at module disassembly, this is where we go ahead and proceed with blade removal, vane removal, the casings are being removed, individual seals are being removed, bushings, and so on and so forth. We've managed the entire disassembly of the engine and its modules in a standardized TAT. Regardless of the engine's condition, how badly worn the individual parts are, or what the work scope may be.
Behind me, you'll see how the fan blades are being removed from the engine. Now let's take a look what exactly it takes for all these parts to be cleaned, inspected, and repaired. Can you imagine what an aircraft engine must endure during its lifetime? From minus 60 degrees to one of the aircrafts in the air, to 1,000 degrees once the fuel is being ignited and pushed through the turbine. From 30 to 35 bars of pressure once the combustion takes place. Then from hot and heavy environments such as deserts with ingestion of lots of sand and dust, to landing in Arctic winds and snow. From being switched on and off a couple of times a day. Therefore, a large variety of materials, coatings, and systems are being used to withstand these harsh environments. From lightweight parts like composite parts and aluminum and titanium for structural application and weight saving, to heavy nickel and cobalt-based superalloys for the hot and loaded parts of the engine. In order to keep costs and TAT down and increase our flexibility, we need to have a high standard of capability on these parts. Well, we've got you covered.
In the moment we are in the cleaning shop where we're performing a cleaning of different engine parts. Those cleaning processes can be very simple and very complex, including the real chemical reactions. Cleaning processes are very vital and critical for accurate entity inspection.
With the eddy current robot inspection system, we induce an electromagnetic field in the material and scan it back for possible discontinuities in the material, such as cracks, voids, and possible inclusions.
FBI is a method that uses capillary effects to penetrate a possible crack in the material. After removal of the excessive fluid, a developer is used to develop the part. After the development time, the part is inspected under UV light.
Having cleaning and NDT process complete, it is time to start our inspection. During this inspection, all geometrical and visual inspection criteria are being checked. If such defects are identified, imprint measurements provided with a 3D microscope are used to define the correct disposition. This provides transparency throughout, from the inspector, engineering, the manufacturer, and the customer. Only on these data a correct disposition can be determined, which can be very cost sensitive.
Unser Wagen jetzt, der ist abgenutzt, den müssen wir aufbauen, der vorne dran auch. Machen wir einen neuen Grundprozess, der Turbine-Pilot hier ist auch abgenutzt, den wir auch neu aufbauen. Bei uns in der Inspection prüfen wir Teile auf Beschädigungen, prüfen, auf kleine Nicks. Wir prüfen sie auf Masshaltigkeit, prüfen. Die Sitze, die abgenutzt sind, können wir neue chromen, blenden. Wir können in der Galvanik Knickel aufbauen, dass die Teile nachher wieder verwendbar sind.
This ensures the correct repair procedure is chosen for the restoration of the performance and build-up related features, the structural integrity. This guarantees the solid build-up of the engine.
After the vital process of masking the areas not to be coated, the plasma process heats up the coating powder to over a few thousand degrees into plasma. The powder is then sprayed onto the surface and cools down to form a protective layer on the base material.
During the plating process, parts are submerged into a liquid which contains the plating material. Using an electrical current, this material is deposited onto the part in order to protect the part or surface in question from corrosion, fretting, galling, seizing and build-up.
Right after disassembly is completed, the material streams are divided into 3 individual streams. Internal repair into our SR Technics Center of Excellences, external repair by carefully selected vendors, and material replacement if the part is deemed unrepairable. The goal is to have all 3 material streams come together at the right time for subsequent quality checks and assembly.
runway 29 is cleared for takeoff.
Im Wareneingang prüfen wir jede eingehende Sendung nach folgendem Schema. Zunächst werden Pakete entladen und nach Herkunft dort vorne sortiert. Das gesamte Material, welches für die Triebwerkinstandhaltung einkommt, wird in folgende Ströme eingeteilt. Neuteile, reparierte Teile, Kundenmaterial, überholte Teile, Verbrauchsmaterial oder Rohmaterial. Auch Einzelteile, die wir vom Händler über die Motorenwerkstatt reparieren und gehen nachher wieder zurück. Darüber hinaus tun wir auch Verbrauchsmaterial und Rohstoffe verarbeiten, die für die Wartung der Triebwerke und von den Teilen bei uns benötigt werden. Noch etwas zu der Statistik. Wir haben bei uns pro Jahr 70'000 Frachtbriefe, 130'000 Pakete und 11 Millionen Bewegungen, die wir durch das Jahr durch verarbeiten. Das macht mich sehr, sehr stolz.
Once the parts have been sent for external repair and the exact need for replacement material has been defined, our material and repair purchasing specialists are managing the entire supply chain until the material is back on site. On average, this can amount up to 5,500 parts per engine. The right material at the right time, at the right place, all the time. Here at Inspection, the qualified and certified inspectors are inspecting every individual part for correct amount, configuration, and certification verification. This involves every single part that goes back onto the engine. The number of checks performed in order to guarantee that all the maintenance is carried out correctly and according to customer specification involve over 350 individual fits and clearances for engine and module assembly, over 1,000 different modification standards, over 550 different modifications for the core engine alone. And this involves over 6,000 individual parts, accessories, and modules. This takes dedication, precision, and a keen eye for quality. So how do we manage this entire process? By using lean continuous improvement.
Lean continuous improvement philosophy teaches us to provide perfect value to the customers, delivering our services within the highest quality, at lowest cost, and in the shortest lead time. We support employees to develop their skills and capabilities through lean trainings enhanced with case study activities guided by our lean agents. By implementing lean continuous improvement philosophy, we have been able to achieve reduced warehouse capacity of over 45%, increased productivity of over 65% on our advanced coating stripping, decrease of non-value added time of over 40% by introducing a first in, first out concept for cleaning and inspection.
So here we are. All the parts have been inspected, repaired, or replaced according to customer specification with the right amount, the right time, the right configuration, verified and certified with Swiss quality. During assembly, exact procedures are adhered to ensure the highest quality standards SR Technics has to offer are being applied to ensure rigid engine build. The numerous parts and their specific configuration and location are assembled piece by piece to last the entire duration of the lifespan of the engine. By using dedicated and high precise equipment to ensure exact geometric tolerances, we can achieve the highest level of refurbishment in the aviation industry. Only by our relentless focus on quality, our years of experience, and our continuous drive for continuous improvement, we can strive for operational excellence during engine build. The joining of rotors with their stators confirms the defined limits and ensures the correct performance needed for engine operation. Installing the high-value parts of the engine takes a keen eye for quality and a strict adherence to standards. When the engine is assembled, the engine is brought here to the preparation hall. This is where we dress the engine with all the necessary equipment and sensors that is needed for engine testing. We test the engine for every possible engine parameter, temperature, performance, vibration, pressure, you name it. We'll run the engine through its paces. Here we are, the engine's assembled, tested, and final inspection completed, with every step verified and certified with dedication, commitment, and Swiss quality.
Wind 3 4 degrees, 3 left and 3 2.